As promised, I wanted to do a brief video on some tips and hints for Project 7. These would normally come out during discussions in class, but because we can't meet, I thought I would do a quick video to hopefully give you some help. Let's look at the two class templates that are shown. So we have two templates that look largely the same except for two things. Number one is that the names are different, and number two is the direction of the comparison that's made. Okay, so each class template has a single type parameter. So both of these have type parameter T. Okay, and T then is used in the actual function header. Okay, and they have a single public Boolean function called first better. Okay, and both of these have the same named function. The only difference is that bigger better returns true if first is greater than second. And that's not a greater than or equal to, that was just underlined. Perhaps I should circle this rather than underline it. And smaller better will return true if the first parameter is less than the second. Okay, so let's keep those two templates in mind as we move forward. Now, if we want to create a class that manipulates data mechanically in specific functions, what do I mean by mechanically? I mean the types of things that happen when we're sorting. For instance, we move data in a specific manner. When we're enqueuing things or when we're heaping things, we move data by a specific set of rules. So that's what I mean by mechanically. But let's say that we wanted the outcomes of the data manipulation to be different based on the result of a comparator. Okay, so for instance, what I mean here is, let's say we want an ascending sort versus a descending sort, or we want the descending sort rather than an ascending sort. The mechanics basically stay the same. It's the comparison that determines which way we should move the data or whether we should move the data. So the way that we can do this, if we wanted such a class, is to write two blocks of code with the exact same mechanics, but just use less than in one and use greater than in the other. Okay, so that's how we would do sorting, say, in descending order. We could do it that way, but we could also write a single block of code that does something like, for instance, insertion sort, and we could pass to that code a comparator, a custom comparator, which would then determine would help us to determine whether and how we should move the data around. So code duplication, as you all know from way back from CS1, is something that should be avoided. It requires that we update code in multiple places. Changes may not actually flow correctly, and so it's just not considered good practice if it can be avoided. So the mechanics of something like insertion sort, as I mentioned, they're the same whether we're doing ascending sort or descending sort. In other words, if you remember insertion sort, we only reveal one data element at a time, and then we compare that data element to all the data elements to its left, in quotes, because there is no left with respect to arrays, but we compare them with the data we've already seen and try to decide whether or not we should move that data. So let's look at the mechanics of insertion sort Instead of relying on the less than function, let's rely on a custom comparator called should move left. And so this is a Boolean comparator, and it would tell us true if we needed to move that data item to the left, or false if we did not need to move it. Okay, so let's look at an ascending sort. So as mentioned, if we have a single data element in an ascending sort, that data is already sorted. So let's imagine that we have the value 5 in our data, and 5 by itself is already sorted. Let's say that the next value that we reveal is the value 8. And what I'm saying here is we would call our function should move left, and it would return true or false. This is an ascending sort. So this should return false. I should not move the 8 to the left at all. It is already in place. Now let's say that we then reveal value number 2. Okay, and so that's the rest of the array. We reveal value 2. Well, in this case, should move left would return true. The data would look like this. The 5 is here. The 8 is going to be here. And you'll recall the 8 is also here because 2 is in temp, okay? So temp equals 2 here. Let's put that in there. Okay, and so we've decided that yes, I need to move the 2 to this position. We would then ask, do we need to move the 2 to the further to the left? And so we would ask that question of our custom comparison, and it would say yes, and then we would end up with this. We would basically copy the 5, as you'll remember. So we would end up with a 5, and then another 5, and an 8, okay? And in this case, this location is where the 2 is going to go, so the loop terminates and we put the 2 in. And so we have 2, 5, and 8. Okay, now that's an ascending order sort. Let's take a look at a descending order sort, and let's use our same custom comparison. Should I move this number to the left? Okay, so we're going to do a descending order sort. So let's label this. And here's my data. Okay, and I'm going to say that 13 by itself is already sorted. So now I reveal the 9. And I ask myself, should I move the 9 to the left? For a custom comparison, that is for a descending sort, the answer to this is no, just as it was above. We answered no here. I shouldn't move the 8 to the left of the 5 because that was an ascending order sort. So in this case, it's a descending order sort. So I don't want to move the 9 before the 13. Okay, and at this point, we reveal the next value, 16. Oh, wow, well, 16 needs to be moved to the left, so I call my function, and it says, yes, you should move 16 to the left for a descending order sort. And so we end up with 13. So in here in temp, we put 16. And then we have the 13 and the 9, and we copy the 9 here where the 16 was, okay? And now we're here, and we ask should and so we're asking, should the 16 be moved to the left, right? Because this is what we're trying to place. And the answer to that is it should be moved to the left, because it is greater than the value 13, and we're trying to do a descending order sort. So we would end up with something like this. And at the termination of the loop, we would copy temp into this first location, giving us 16, 13, and 9. So I kept these two examples sort of symmetric to one another because we did the exact same thing. It's just that we did not use less than in this top one and greater than. We used a custom function called should I move it to the left, and it answered yes when the value was smaller and we were doing an ascending order sort, and it answered yes when the value was larger and we were doing a descending order sort. So you notice that this is now sorted in ascending order, and this is now sorted in descending order. So then it is the comparison that decides the sort order. It has nothing to do with me having to duplicate all of the rest of the code in insertion sort to make this happen, right? The mechanics stay the same. It's basically in a couple of locations that I may have to substitute this custom comparator function. So the question then is, how can we accomplish both behaviors with a single block of code, differing only by the comparator that they use in that particular for the various comparisons that it makes? So one of the ways to do this is by using a class template for which one of the type parameters is itself a comparator. And that comparator may be a template itself, right? So we've got sort of the possibility for nested templates here. As we saw before, and I'll back up for a second. So these are class templates, which are comparator classes, and they both have they both take type parameters. So let's look at the class on the right, which is a class that basically uses a custom comparator. Okay, so you notice that I named it, I gave it a very long name, class that uses comparator, because that's the point I'm trying to make here. This class is a templated class, okay? So it is a class template, and it takes two type parameters. You see type name twice, followed by type 1 and then type 2. Type 1 is called item T, and type 2 is called a comparator T. So so these are the two. So let me write this down. That so this is item T, and this here is comparator T. Okay, you notice that the class instantiates, we can disregard that semicolon, it instantiates a comparator object. Okay, it instantiates a comparator object. The constructor in this case takes two parameters. It has two parameters. The first parameter, you notice that both of them are of type item T. The first one called item 1, so this is the type, this is the variable name, just if we had int I and int j. Okay, so this is the type and the variable name, or the parameter name. It pushes this into a vector, pushes the first item into element 0 in essence, and then pushes the second item into the back of the vector, which is into element 1. And then this particular function is pretty boring. It doesn't do a whole lot, but it does return the result of whatever comparator we passed in, okay? How are we getting that? Well, this comparator type was instantiated as an object right here called comp, and that object here is the first better function is called from that object, okay? And so it's a rather boring function. There are no mechanics here. This is not insertion sort, but I wanted to abstract away all of the details and just present the how. Okay, so it uses the instantiated comparator object. If this comparison is, if the comparator that was passed into this was the bigger, better comparator, then this function would return true if the first element is, that is the element at vec index 0, if that's greater than the second. If, on the other hand, what we passed into this was the smaller, better class template, well, we would then, it would return true if the first element was less than the second. Okay, so this works. The reason why this works is that we're guaranteed that this function exists regardless of what we pass in to this class. Whatever comparator I pass into this class and I instantiate here, it is guaranteed to have a first better function. So I know you're seeing the parallels here. It is why I required that you have a similarly named function in Project 7. So again, this class doesn't do much, but if we assume that it was handling some sorting or some priority queuing, then hopefully the use of this custom comparator should make sense. So I'll sign off with just a couple of hints for you. You know, here's the syntax basically for instantiating a class template object with multiple types, and class name is not a kind of a keyword. That's like the actual class name, like gas pump or motorcycle or whatever. And then you just list all of the types in a row until you get to your last type, and then you give it the name. And so the other clue that I will give you is that something like bigger, better int it's a comparator type. It's a type that can be passed in to a as a type parameter to a class template. I hope this helps you with Project 7.